Hi guys and welcome. It's another box. What's in this one? Should be a Creality Ender 2. So let's get it open and take a look. And if you're wondering why, well, it was simply that I saw this one on offer and it was just too good a price to pass up on. And curiosity got the better of me, so here we go. Yeah, so this, well, it certainly says it's an Ender 2, and in here we have got some bits of paper and some tape that's securing a foam lid. And this one, to the best of my knowledge, unlike the Ender 3, this obviously came before the Ender 3. Unlike the Ender 3, this one is an actual true kit and has to be assembled from the ground up as a kit. So this should be quite interesting. I'm looking forward to it. Right, so there we go. I'm going to get everything out and we'll have a look and see what we have. We're going to take a look at the contents of the box which have been unpacked. So the first thing we have is the base, which is, so I suppose you could say, slightly pre-assembled, although it's literally just the power supply, which has the USB and micro SD connector, the dial with the selector switch much like the Ender 3, a small screen at the back here and the power on off button. Attached to it are all the wires which connect to the heated bed and to the stepper motors, and also attached to it are the wires for the hot end for the heater block, the heater cartridge and the thermistor. And it's a standard hot end. We'll be looking at this in detail a little later in the build because I'm going to completely strip, check and rebuild this, which is something I recommend that everybody does on one of these before they begin to print for their first print on this type of hot end assembly. And I will explain that in more detail later. So we'll move that one aside. And I've neglected to mention we have a parts list so you can check off what you have. We have installation instructions which give you a step-by-step, and then on the back some information about the power supply, and then we have a warning specification which is just a general common sense stuff and your declaration of EC conformity. We have a multi-part spool holder which simply fastens together with a couple of plastic screws. Your spool sits on there and feeds your filament. We have a UK 3-pin plug with spade type connectors, so they screw into the power supply. It's not an XT60 connection like the Ender 3 is. And the power supply in question is here with a removable moulded base, and you can see the screws that you fasten the appropriate connectors to. In this piece here we've got two tensioners for your belts and a limit switch. We have two further limit switches here, so we've got a limit switch for each of the axes. Over here we have the heated bed, which has to be assembled onto the bed plate, which is this one here. So this fits onto the rail that slides back and forth on the y-axis. Your heated bed then, oh, I can pick it up. Your heated bed screws down onto the top of that, and this is of course adjustable. This is how you raise and lower to set your level, so you can change the overall height and angle for when you're leveling for printing. You have an option of masking tape or painter's tape type bed material that you can stick onto the surface, or the piece of glass is just a little piece that I cut to try myself later, or a build tack type material, which is most likely the one I'll use because I do like the build tack on the Ender 3. So you've got a choice of build surfaces there. And then, as I said, this is the bit that goes onto the rail that your bed fastens to. We have 2 Ziploc bags. One contains a filament sample, a USB card reader with a micro USB stick, and I think that's a guarantee card, but it's all in Chinese, so I'm not 100% sure. And then the other bag contains all your fixtures, fittings, screws, bolts, drive belts, and tools. So you've got a pair of nippers, a screwdriver, Allen keys, zip ties, spanner, and that manner of thing. This big lump here has 2 stepper motors. One of these is the extruder, this one at the top here. This is where you feed your filament through and it comes out there along the Bowden tube. And then this one here is your X-axis drive motor, and this is what moves the hot end left and right. This one is your Z-axis drive motor, as you can tell by the coupler and the fitting there. This fits on there, and inside of it fits this threaded rod like so, and that drives your height. That sends the print head up and down, and that of course leaves the Y-axis stepper motor, and this is the one, this is the one that moves the bed back and forth. All the stepper motors are essentially the same thing, so there's nothing special or unusual about them. They're all the same thing. They're just already sort of pre-fitted to their mounting plates, so that you just put them straight onto where you're going. And then in addition to that, we have 2 extrusions, one for the upright and one for the cross piece that moves up and down it, and these have little prettification inserts in a nice shade of blue. And is there anything we're missing? We have a scraper, which is in the box still, because that's just to remove prints from the print bed. It's just your standard scraper. And a needle, which is for unclogging the nozzle if the nozzle becomes clogged. And I think that's it. The needle, the nozzle, the needle, the scraper, and then everything else is on here, plus the bed that you saw at the start of this. So that's everything. So what we're going to do is start with the build. And a couple of little recommendations. If you have some decent tools, an adjustable spanner, a socket set, and Allen keys, decent Allen keys for example, I recommend that you use them. The ones in the kit can be used, but if they're like the Ender 3 ones, which I suspect they will be, they're not the very best of quality. They're adequate, but they're not the very best of quality. When you're loosening and tightening, whether you use good quality ones or whether you use the ones in the kit, use this end for loosening and tightening, the flat fixed one, not the ball end. The ball end should be used for unscrewing loosened nuts or tightening up loose nuts, basically driving it in or out. When you're tightening or untightening, you need to use this end so you have much better, more solid connection. And this, I think, is the reason that most people tend to strip the bolt heads, because they're a fairly soft metal and they're using the ball end, which is designed to be flexible and allow you to drive things in more quickly at an angle, that kind of thing. So if you've got some decent tools, pull those out and use them. Allen keys, adjustable spanner, socket set, screwdrivers and the like, because that will give you less chance of damaging something, because the parts included are enough to get you going, but they're not brilliant. The spanner, for example, is not great quality. It's just a stamped metal thing, and the screwdriver again is not the best quality in the world. So do yourself a favour and use some decent tools if you have them. And if you don't, and you're planning on tinkering with 3D printers and the like, buy yourself some decent tools. They're not that expensive. Pop along to a tool shop, get yourself a decent set of metric Allen keys. They will last you for years and years and years, with as long as you look after them and use them properly. So that's the contents we're gonna get to building. Stage 1, it shows here, is essentially to get this with the hot end. So that's already pre-assembled, so that's not really a step as such. So step 2 is where we're going to start, which should really be step 1. But in step 2, we are going to fit the Y-axis stepper motor at the back and the plate for the build plate to bolt onto the Y-axis. So step 1, which is step 2 on the diagrams, we take the stepper motor and install that. And when you install this, you slide it in, you get these things that are called hammer nuts, and they look like this. They're angled, these things here. So they'll slide in, they'll slot into the extrusions one way, and as you tighten them, they'll spin round and then jam inside the channel so that you can tighten the screw down onto them, and then that will allow it to tighten up. When you loosen them, they will naturally twist back and you can pop them out of the channel. So you slide those into the channel. There's 2 of those already on. You slide those in, tighten them up just so that they're just nipped up, and then line up by eye so that you've got a fairly even gap down each channel, because this is where your belt will be running, and you want to try and avoid getting your belt snagging. You might need to, don't tighten these too much just now, because once you fit your belt, you might need to jiggle this up and down a little bit to make sure that your belt doesn't snag or rub on the channels. The second part of the step is to fit the sliding plate. So before you go ahead and fit it, check that these are nipped up. You don't want to really wrench them down too tightly because you might crush the centre bearing. So these screws bear onto the centre of the bearing race of the wheels. So you just want to make sure these are nipped up. These are nylock nuts, so they shouldn't come loose, but one of these was actually a little loose for the eccentric there, so I just nipped those all up but made sure that they all spin. And then you need to adjust your eccentric nut, which is this one here, which has got a hole drilled off centre, and as you rotate this nut, hopefully you'll be able to see, as you rotate this nut, it will move this wheel in and out accordingly, allowing you to tension the bed, and exactly the same for the extruder and all the other axes. What you need to do to make sure this will slide on smoothly is wind that so that the face with the hole nearest this side is this way out, and this will leave the biggest gap. It needs to be installed with 2 wheels on this side, 1 on this side, and what you do is you just guide it into the channel and it should slide on freely like so. That's actually pretty good, and it won't need much tensioning when I do get around to that. So that's the first 2 bits installed. The next step is to take one of the belts, so I'm just going to grab the first one that comes out of the packet. They should both be the same length, and they should have a brass crimped end connector on them, and this allows for easy fitment. I'll put that one safe back in its bag for now. So what you need to do is thread the belt down this central channel until it pops out of the other end, and it wraps around the toothed cog of the stepper motor. Obviously you'll notice one side has teeth, on the other side is smooth, and then you need to feed it down this channel and through this little hook section here, so that the brass bit sits on the top and prevents it from slipping back through. It's trying to do this so you can actually see it, hopefully. So you're basically slotting that through like that. That goes round there and pulls through here, and oops, got that twisted somewhere along the way. Make sure I've got that the right way round. Oh, yeah, there we go. So the same with this one. You're slotting it in and twisting it round, then pulling it down so that the brass piece actually bears against that. You'll notice at the moment that's loose. That's because the tensioner needs to fit onto here, but you'll see now that by turning this, this will move this plate back and forth accordingly. I do actually need to raise this now, because as I suspected after I'd mentioned centering it, it is actually going up through the groove now, so I need to lift this stepper motor so that this belt is above the groove so that it doesn't wear away on the channel, and there should be enough space in the channel at the back to allow that to clear the bottom. So you'll see there I'm wiggling that up because I've not fully tightened that at the moment. I'm going to need to loosen that bottom one a little bit, but I'll go ahead and do that and then spin it around and show you. So we're here at the back of the printer again. I've just jiggled that around a bit, and it's actually a little bit tricky to gauge that until the tension is on and the belt's held under tension. So what I'm going to do is wait until I've fitted the tensioner and tighten that that drive belt accordingly, at which point I will then look at the path that it takes. But what you're essentially trying to do is prevent this belt from rubbing against anything that will wear it prematurely. So I'm sure you can sort of understand what I'm talking about there. So that's what we need to do with that one, but it will need to wait until the tension is fitted so that I can see exactly, because as you can see it's just far too slack at the moment to gauge that properly. So on to the tensioner, or as it's referred to on the sheet, the Y passive block. This basically it's a tensioner. You slide it in and out to adjust the tension of the belt. This is the one that goes on your Y axis, which is differentiated by the one that goes on your your X axis, by the fact that this is stepped and uses both channels, whereas this just uses the one channel of the X axis. Same idea with the fasteners. It uses the hammer nuts, which slot into the extrusion. You need to wiggle them around so that it fits. And once those are in, you can see I'm actually going to have to pull that stepper motor back as well to further tension this. So once those are in, we just nip those up just enough to hold it in place. Sometimes you might need to unscrew these fasteners a little to make sure that the hammer nut actually drops into the channel adequately to allow it to turn. And because that was pretty much at the limit where it was starting to get tension on the belt, what I'm going to have to do is move the stepper motor back so that I can now properly tension the belt, at which point I will be able to adjust the tensioner and the stepper motor to make sure that the belt has clearance both front and back. So now we've got this lined up pretty much at a decent point. I'll try and show you if I can. It's kind of difficult because let me see if I can get behind the camera and see where we are at. It's going to be a little bit tricky to see, but hopefully you can see we've just got clearance. Obviously as we come closer, the belt lifts up because it's going up into the plate, but as it comes along, you can see it gets closer to the top of the extrusion there, but it just has clearance all the way along front to back without the belt actually rubbing anywhere. It needs tensioning up a little bit more. That's way too slack currently. So I'll need to tension that with the adjuster at the front once I've tightened up the screws on the stepper motor. Mounting plate, mounting it to the frame, and then underneath there, again difficult to see, but that's just clearing that there. So it's very fine. You're left with a very slim gap, but you need to make sure that it's not rubbing, because the rubbing will either snag and cause jumps in your layers as you're printing, or it will gradually wear away the belt much more quickly than it would do in normal regular use. Bear in mind when you're building these as well, you may need to, after your first week or so, you may need to go around, recheck and retension. So what I'm going to do now I'm happy with the position of that one is I'm going to tighten up. So using this end of the Allen key, I'm actually using the one supplied in the kit, and what I'm going to try and do with this build as much as possible is use the supplied tools, because I know some people who get one of these or any 3D printer for that matter will generally be stuck with the tools that they have in there. So just to show that it is actually possible. So what I'm going to do is tighten these up, and as I say, when you tighten, make sure you use this end so you've got a good fit in the bolt head, because this end you are likely to strip things, and then that just gets very upsetting because it makes them very hard to remove. These type aren't too bad because they're raised. You can actually grip them with something like mole grips or pliers, and often get them to loosen. But the cheesehead ones, like on your heatsink, are just just a nightmare when it comes to that. So that's that one. We're quite happy with that. And what I can do now is tension the front one. To tension it, get yourself a screwdriver or another one of the hex keys, slacken off all of the bolts, so loosen and then just tighten them up so that it's just kind of gripping, so that it's loose but not sort of slopping about. And then take your second hex key or a thin screwdriver or similar and use that as a lever in here to pull this out until you've got tension on there. And you're looking for a twang. It's kind of hard to get that on here, but hopefully, if I move my microphone closer, hopefully you can hear that. That's giving you kind of like a guitar string twang. And that's essentially what you're looking for. You're looking for a twang tightness. It needs to be nicely tensioned. That might still actually be very slightly loose, in fact. Yeah, just a little. So, but it gives you the general idea. And as I say, you can use something like this to actually tension it. And I am going to deviate from that, and I'm going to use one of my own slightly heftier Allen keys for this. So keeping an eye as well on the actual tensioner, because it will sort of wiggle up and down a little bit. So try and keep an eye on that so it's not deviating too much. And you can lever it from the bottom like that and from the top like that until you've got it nicely positioned and at a good tension. Just checking the underneath channel to make sure the belt's not going to rub on there. Get that a bit of clearance. Yeah, quite happy with that. So then we'll just nip that up. I'm just going to slacken that one and retighten it to make sure that it's actually properly in the channel. I think it is. Yeah, you can see that that is. And just nip that up. And then going to run that back and forth. Make sure that the belt's not catching anywhere and it's got a smooth movement, which it has. Got a decent tension on the belt, and then tighten them up with this end. I think that might actually be just ever so slightly loose, but we'll see how that goes. But once you're happy with the positioning of everything, the tension of the belt and the plate, the next thing to fit is the Y limit switch, which is a little micro switch. And this bolts onto the rail at the back here and is activated as this plate slides back and hits the switch and tells it that this is where the Y limit is set and where it has to stop. You can adjust where this stops by sliding this back and forth accordingly. For the moment, I'm just going to mount this right at the very back there, and then we'll adjust that once it's up and running. So same principle as before, bolts with hammer nuts and it's on a plastic mount with a little board there, the plug that one of these will go into, and the micro switch. And just a quick note on the Y-axis limit switch. The instructions show it to be mounted into the bottom, so it's actually the wheel of the plate which hits the switch and activates it, rather than the plate itself, which is what I thought it would be. So I'll build it according to how the instructions have it. So we'll have it set like that, and hopefully that will be okay. The next step in the build process is to fit the upright, which is the wider of the two supplied beams, which locates on this position here, and we have a locking right angle connector using 2 bolts and hammer nuts, which fits in and slides in this rail and connects the 2 pieces together and locks in to keep this upright straight. So we need to fit the upright with the trim pieces to the front. Doesn't really matter about that, because you can always take them out and move them if need be, but obviously the trim pieces are already in, so you fit them to the front, and you need 2, and get them out of the bag. Oop. 2 of these supplied bolts which bolt in from the underside of the plate. Oop. So these slot into the pre-drilled holes here and here, and the extrusion bolts on through the pre-drilled holes in its base. Like so. And before I tighten those, I'm going to fit the right angle connector. And this will ensure that this beam is straight. Now that we've installed the upright and we've got it tightened up so it's nice and firm, it's starting to look a bit more like a 3D printer rather than just a base with a few bits bolted onto it already. And the next step after this is to install the stepper motor and the Z lead screw, or the T-rod as the instructions refer to it for some strange reason. The instructions are actually quite basic and don't really describe a lot of the assembly steps as you come to certain bits, and this will become more apparent on the cross piece, that the Z lead screw moves up and down, as we'll see when we get to that. So this fastens in behind the stepper motor behind here, and it's the one with the flexible coupler on, and then the Z lead screw fastens into that. So taking the Z motor, which you can tell because of the flexible coupler and the mounting plate here, using the hammer nuts as per previous, we slot this into here and it bears onto the base, so it sits on the base. And taking the appropriate sized Allen wrench, you loosen the hammer nuts off until they move freely into the channel, and then turning it clockwise will rotate the hammer nuts so that they lock into the channel. And tighten that, wind it in with the ball end, flexible end, and then tighten as per previous instructions with the straight end. And if it becomes necessary at any point, although it's not something I've heard of being a problem with the Ender 2, but a common problem with the Ender 3 is misalignment of the Z rod with the plate on the X-axis. So what you can do is print shims off Thingiverse that allow you to shim this in, shim this out, so that you can help align the Z rod if that becomes a necessity. The Z rod is simply a case of dropping it into here and tightening the Allen bolt. However, something to mention, when you look down into this, you'll see the stepper motor shaft coming up, and it can sometimes protrude up through the coupler. So what you want to avoid is the stepper motor shaft and the coupler actually meeting, because that's going to minimise the flexibility of the Z lead screw if needed. So as in this case, if I can actually get this Allen key to go in, if it wants to behave. If I got the right sized Allen key, maybe? Is it the wrong size Allen key? No, it's the right size Allen key. It's just me that's not it's not fitting in for some reason. Nah, okay. Obviously got the wrong angle. There we go. So using the appropriate end, loosen this, lift the coupler. I don't know how visible this will be, but you'll see that there's a step inside there, which is what the Z lead screw will sit on. And this coupler can actually travel up through past this, so it's actually touching on the Z lead screw, which you don't want. So you need to move this back down so that it's just under the chamfer. You'll see a little chamfer on the edge of that. So it's just under the chamfer, which means it's got enough, it's bearing on the coupler enough to have good grip, but not so much that it's going to bear onto the lead screw shaft itself and potentially cause Z binding problems when you start using it. So tighten that up nice and tightly, and there's now a little bit of a gap in there. And then what I like to do, just for what I like to do, just to be absolutely certain on things, is to drop the lead screw in and lift it just very, very slightly, so that it's effectively about 1 millimetre off that plate. And this is what I did with the Ender as I was going through the process of tuning it to try and get rid of Z banding issues that I had. And without having to use a shim or anything, it certainly seemed to have solved the problem. The Z lead screw seems to be quite well oiled on this compared to the one on the Ender, so do be careful. I'm going to leave the sleeve on that until I've got that all together, so I don't get oil or whatnot on any other bits. What you can do as well is, if you look through this little gap, you can actually see if the Z lead screw is butting right down onto the thing. So what I did with the Ender is I looked through that gap and I lifted this just enough that I couldn't see it. So essentially you're lifting it about 1 millimetre, that's all. Make sure these are both really nipped up tight, because this can also lead to problems on your Z axis if they're not really nice and tight, because as it turns, if it's not fully tight, it can slip, which you don't want. The next step is the Z limit switch down here, which has 2 T-nuts which go into the channel, and a screw which goes through a slot at the bottom and into the mounting hole below. So I'm just going to nip these up first. Same procedure, make sure you unscrew them enough to allow the T-nut to rotate into the channel so that it binds properly, like the bottom one hasn't. So I'll redo the bottom one first. Because you can't see that, it's sometimes easier to do the ones that aren't easily visible first, so that you can feel and tell if they're actually binding into the channel. Because sometimes they don't go into the channel deep enough or rotate. There you go. Now that's not coming out, so I know that that's actually rotated and it's binding into the channel properly. And then the top one, of course, you can actually see whether it does. It's just a matter of tightening these up. And then the bottom one is just a case of, a little bit fiddly because the wires are kind of in the way, but it's just a case of feeding that in until you find the thread, like so there. There we go. Oh. I'll say a little bit awkward to start with because it's on an angle, and then just wind that in, tighten this up, and this is this part of the assembly done. And on to the next part of the build, which is the x-axis. This is the bit that moves up and down the z-axis. This is the extruder. Your filament goes through here, comes out here along the Bowden tube to your hot end. And this is your stepper motor for the x-axis, which your hot end slides along on this extrusion here. Now you'll notice on this extrusion there are two pre-fitted bolts and hammer nuts on here which are going to fit into it, and on this extrusion you've got a little cutout. Hopefully you can see that fairly clearly, but you've got a little cutout on one end. This is to fit over the round bolt here for this eccentric adjuster. So what you need to do is lining up the T-nuts and lining up that hole so that it matches accordingly, is slot that into there until it sits flush. I'm trying to do this so you can actually see it on the camera and making a bit of a mess, dropping everything. But that's, if you've not got it right or you've got it the wrong way around, let's say we've just put it the wrong way around, the T-nuts will drop in like so, but you'll see it will sit proud there. So this is why it's important that you get it the right way around with that cutout, so that as you drop it in, if it's not in the right place it won't sit right, but as soon as it is, that will drop into that pre-cut groove there, like so. And then at this point, putting your Allen key through the holes on the back of the plate there, and using the same method as previously, loosen off so that the T-nut drops into the channel and rotates, and then tighten them up. Again, we'll do the one that's not easily visible first to make sure that it actually fastens, which it has done. And then we'll go on to the one that's more easily visible, which you can check visually by looking at the T-nut on this side to see that it's actually fallen into the channel as you tighten it, which, there we go. Hopefully you can see that on the video. And you need to make sure that this is level with the top of that plate, so that when it's mounted, this axis is level. Once you're happy with that, make sure you've run them up as tight as you can with the ball end, and then using the flat end through the gap, fit and tighten them so that they're good and solid. On the other end of this is your tensioner, which is exactly the same as the one on the y-axis. Two bolts with hammer nuts that go into the channel and fit on the rear. This particular type of tensioner could fit on the rear or the front, but because this has the fancy trim in the front, you would fit it on the rear. You can of course just pop this trim out if you didn't want it and fit it on the front. It doesn't really matter as regards that, as long as it's on there, because that tensions the x-axis belt. Once we have got, the belt goes through the tooth stepper there, over the tensioner there, and hooks into the extruder, much the same as the base plate, which you'll see in a moment. For the next step, before we put the hot end on, we need to mount this onto the upright. And to do that, you slacken off this eccentric nut to its fullest, so that it's as far out, this wheel is as far out as it can be. And then you simply sit this on top of the extruder, lining up the wheels with the slots, and feed it down. And interestingly, and I'm actually kind of glad that this has happened. Let me move this up a little bit so you can see better. But that's really tight, even with the eccentric wheel at its loosest, because there's not quite enough room. And I had the exact same problem when I built my Ender 3. And at first I thought that was just how it was supposed to be. You can kind of force it, because of the rubber wheels it will go. But what you'll find is you get a very, very tight Z-axis that for travelling up and down there. So what you need to do here is the following. With this axis removed from the printer, you need to loosen these two bolts and their corresponding lock nuts at the back. And these are the two outer wheels. And then you need to push these as far this way towards the stepper motor as you can, and retighten them. This will give you just that little bit of wiggle room, just enough wiggle room to make sure that this actually has a smooth but loose enough fit on there, and then you can take up the slack with the eccentric adjuster here, which is precisely what you're meant to do. So essentially you're slackening these off with an Allen wrench at this side and the spanner at the other, as these are lock nuts and they will not rotate freely. And then you'll notice you've got ever such a slight amount of wiggle room. So you need to lock this as far over to this side as possible and retighten that lock nut. And this is where you could ideally do with another hand or another pair of hands, although this might not be necessary on yours if you're building it, but this is a problem that's common with the Ender 3 as well. So I'm going to try and wedge that in there while I push the wheel out and retighten this bolt. Oops. Hopefully this is still on camera. I can't actually see at the moment, but and then it'd help if I was actually tightening it the right way, of course. Foolish me. So just tighten that enough to hold, and that will have moved it over just that little bit. And then do the same with the bottom one, and then we'll reinstall that on the gantry. So now we've adjusted these two and tightened them back up. It's it doesn't give you a great deal of movement, but it will nudge them out just that little bit. There is a tiny bit of wiggle room, and with this on its loosest setting, what we do now is feed it onto the upright, and I've just removed the Z lead screw for the moment, just until we get this on. There we go. And then if you let go of that now, you'll see that that will actually fall under its own weight. It's still a little bit tight, and that is unfortunately as loose as it will go. However, this will wear in after the first few uses of moving up and down the carriage. The wheels will bed in. They will wear a little bit of a groove in there, and it will wear in and it will become looser and move up and down more freely. The one on the Ender 3 that I had the problem with was really tight getting it on to the upright to begin with, but it had a little bit more wiggle room on these, so it made it much looser, allowing me to take up the slack with the eccentric. In this case I will literally not have to take up anything at all until maybe the first couple of prints have been done, when it's loosened up a little bit. But what you're trying to do is make sure that you're not having to force this on and it's not binding, because the motor, the stepper motor, will have difficulty overcome if you've got to really do that to make it move, instead of just moving it like so. So there you go. As you can see, that's now falling under its own weight freely, and once this is on, it will obviously add a little bit more weight. It will fall a bit more freely yet. So so that's a little tip for this, because this seems to be a relatively common problem. As I say, I had this on my Ender 3, and I know I've seen comments from others who've had the same thing on their Ender 3 as well. So hopefully that's a useful one for you. So after refitting the Z lead screw, which I've given a bit of a clean off because it was quite thick with grease. You don't need a lot of grease or lubrication on there. Grease, in fact, standard grease is a bit too heavy for this kind of application, and a light grease or a light oil would be much more suitable, but I've basically cleaned the majority of that off, just leaving a thin film. But once you feed this back on, feed it on carefully so that what you're avoiding doing is nicking the rubber guide wheels. You don't want to do that. And then you feed it down until all the wheels are on the extrusion, and then you just need to feed the guide rod into the brass connector until the threads connect, and you can twist that. The next step in the process, now we've got the X-axis fitted, is to fit the complete hot end assembly with the Bowden tube and the electrical connectors. The Bowden tube fits to the extruder over here, and these wires carry the power to the fan, the heater cartridge and the thermistor in the hot end. On the side of this are fitment holes for the parts cooling fan. I've got a couple of parts cooling fans on order. I will be fitting one of them, and I'm going to possibly try a dual parts cooling fan setup on this and keep the stock hot end, but with 2 parts cooling fans on either side. I have got one scoop for this side, which is from my modified, because I put a modified cooler, the Bullseye, the Pet's Fang Bullseye, onto my Ender 3, which I could do on this one. I could do the same thing, but I'm going to try and keep it stock. But because I've ordered 2 fans because they were so cheap, what I'm going to do is print another cooling scoop and fit one either side and see how that performs, and we'll just see how that goes. So loosen off the eccentric to its loosest point. Make sure these carriers are tight and it's not wiggling going to be loose, and then simply slide these on. These should slide on quite freely, like so. As you can see, it's very loose as is, so you need to take your large adjusting spanner and then tighten up the eccentric to the point where it stops wiggling and feeling loose. The best way I've found of adjusting these so they're not too tight or too loose is holding the extrusion with your fingers and then pressing down with the heel of the hand, or with your fingers, however's appropriate, onto these wheels so that it holds the top wheels firmly. You don't press too hard because you don't want to be digging the wheels in, and then turn the eccentric one with your finger and thumb, and it should turn. You should be able to make it slip, but it should still have a little bit of grip on there. That, as you can see, is moving, which means it's too tight. So I need to back this off. I'll just do that a little at a time until I can actually make this wheel slip as mentioned, like so. At that point I can still feel it's grabbing. You can see it's moving it a little, but it slips as well at the same time, so there's a little bit of friction there, but it's not too tight. The unit itself is nice and tight on there, and it slides nicely and freely, as you can see, which is what we're aiming for. This is why I mentioned about this one being a little bit tight, but that should ease off after a little bit of use. Unfortunately, I can't get that one any looser. Ideally, you'd want that one to be a bit looser so it would move as freely as this one, but we'll just have to go with what we have there, and if necessary, I will have to try and look at adjusting that later if it does bind a little bit. So that's the hot end. You can now, if you wish, take the PTFE tube coupler, and you can either pop it off by holding this top bit down and pulling the tube out like so, and then just screwing that in, and you can knit that up. You don't need to put a lot of pressure on. Bear in mind you're screwing it into a plastic housing. It just needs to be tight enough that it's not going to move, and then slide the PTFE tube back into there until it seats fully down. Apologies if I'm blocking your view there. And that's your PTFE tube, and the wires we'll deal with in a little while. I'm going to separate these before we get to the stage of printing, because I don't like these being cable tied together. I did the same on my Ender, and it does seem to make a difference in how it operates, because these can be too tight and they can crimp the PTFE tube and cause a bit of a problem, and also it just adds an extra bit of stiffness to the whole assembly. So if you separate them, the PTFE tube can do its own thing with the filament going through it. You'll see it sort of flexes and moves as it feeds, and this can do its own thing. But what I'll be doing is using the little clip on the side of the extruder to fix this into. So we'll see how that goes. So that's the hot end installed. The next step is to fit the drive belt. So it's the second of the two drive belts, exactly the same as the first, as you can see, with the brass crimped end connectors. And what we do is we feed that through the slot and over the top of this adjuster wheel. And with hindsight, what I should have done is actually installed this before tightening up that adjuster wheel. So I'm going to now loosen that off and fit that in. Actually, no. Then what we need to do is fit the second of the two drive belts. So what you need to do is feed it into the slot on the top. So you'll be able to just pop those wheels over it like so. Wrap it around the feed gear on the motor and around the tensioner on this end, and you're looking for the little slots in the hot end mount just down here. And as we did with the base plate, helps if I pull the right part. Yeah. Okay, this is kind of tricky to see, but it's essentially just two little slots, and all you're doing is you're feeding the little slots, and the brass connectors need to be facing downward, not upward, because you can actually fit them in the other way around, and if you do that, the brass connectors will be interfering with the underside and will catch and cause friction. So you need to fit them with the brass connectors facing downwards, so the belt's going in at the top and down underneath, and that's the belt now installed. Obviously you can see from that it's very floppy and loose, so the next step is to tension it by loosening the two Allen bolts that hold the tensioner in place, and as we did before, keeping the tensioner as straight as possible and applying pressure with a tool like a screwdriver or another one of the hex keys to pull this out until it's the correct kind of tightness, till you can twang it a bit like a guitar string. And then once you're happy enough with how taut that is, nip up the screws with the hammer nuts or the T-nuts and check the tension. That's not too bad. I think that could do with being just a little bit tighter, but as you can see now, that's not jumping or skipping about on there, and the carriage moves quite smoothly. So as the stepper motor moves it, that shouldn't skip or jump. If the belts are too loose, the whole thing can skip. It can jump, and this will lead to layer skipping, which is where you get layer misalignment. So if you were printing a cylinder, for example, you would get a cylinder going so far up and then it would shift over slightly that way. So you'd get the same cylinder, but you would see it was several millimeters, sometimes worse, over one way or the other. And this can happen because of loose belts. Most commonly that's the reason for it. And if it happens in this orientation, it's this belt that's loose. The other possible reason for that is if your nozzle actually catches and snags and makes it skip a tooth that way, because as this is turning, if something is holding this and stopping it moving, if the nozzle hits a part, that can actually turn and skip a tooth. So that's another reason for your layer shifting. So, but the most common one, as I say, is a belt that's too loose, and as this turns it skips a tooth or two. So That's still very slightly loose. It would probably be okay, but I'm not 100% happy with that. I want it to be a little bit tighter. So I'm just going to slacken off these adjusters again while maintaining the tension. And then tension that just a little more and tighten these up. And that should now, yeah, that's a little better. I'm happy with that. And I know a lot of people, when they first set these up, they're worried about over tightening them. Now these belts are very, very strong. Now you don't want to yank them so tight that you can't move them. I'd say it should have a little bit of a twang when you twang it, and it should feel reasonably taut when you press it, like so. But it certainly doesn't want to be sloppy. It doesn't want to flop about at all. So make sure they're nice and tight, make sure everything's aligned there. And this is your hot end with its drive section assembled. The next step is the X-axis limit switch, which comes with 4 fastening screws, the actual limit switch itself, and a third mounting posts, a fourth mounting posts. The third one, second and first one, being already mounted. I'm guessing they leave this one off to make the feeding of the belt easier, because I can't really see any other reason for that. But it screws onto these like so, and then the carriage, as it moves along and hits the home position, trips the switch like so. So you need to take this mounting post. Anyone that's ever built anything with computers will be very familiar with this kind of thing. These brass sort of risers are commonly used to mount motherboards onto a steel frame of a computer, for example. So you need to nip that in. You don't have a spanner supplied with the kit that will tighten that, but it doesn't need to be super tight. But if you want to get a spanner, an adjustable wrench or something, and just nip that up, you can do. And then the end stop switch is just a matter of it's simply a matter of popping in the screws, and then just nipping them up. Doesn't have to be super tight. This is simply holding, this is a cover that sort of prettifies this a little bit when you're viewing it from face on, and at the same time it holds the trip switch or the limit switch for the X-axis. So we now have the limit switch for all of them installed. So I'm just going to give those a gentle nip. Doesn't have to be too tight, just tight enough. And now, when you home downwards, this limit switch sets the limit height. When you home over here, this limit switch sets the limit for your hot end. And when you home this way, this limit switch sets the limit for your Y-axis. The only thing left to fit now is the plate and the adjusting screws, which come in a little bag like this. You will have 3 screws, 3 springs and 3 adjusting knobs. You can probably, these are quite small compared to the ones on the Ender 3. The Ender 3 ones are great for very quick sort of fine adjustments. You could probably print larger versions of these on Thingiverse, I suspect. I've not actually had a look yet, and that's something I might have a look at, depending on how good these are and how easy they are to level. If it levels and keeps a level like the Ender 3 does, then I'm really not concerned about it. It will work without any problem at all, and I'll be quite happy with it, because I've not had to re-level my Ender 3 in absolutely ages. so I don't see any reason to upgrade something that works. It's taking your build plate, which is a nice, and which should be a nice flat piece of aluminium, and these are fairly good because they're relatively small compared to, say, the Ender 3. What you need to do is take each of the screws in turn, which are countersunk crosshead screws, and then just drop them through the pre-drilled, pre-countersunk holes in the plate, and then adding a spring like so. We need to pop those through the holes in the carriage plate that runs on the rollers until these all drop through like so, and you can see that that has some spring in it, which is where the adjustment is made for the bed level. So taking an adjusting knob, I'm going to pull this forward so I can get to it easily, and I'm just going to spin that on, and then the same with the others. And this one uses 3 adjusting knobs as opposed to 4, one on each corner of the Ender 3, but the principle remains the same. Some people say that a triangular pattern with 3 adjusting knobs is actually easier to level and better than 4. I don't know if that's the case, because I've only had experience with my Ender 3, which has 4, which seems to work well enough for me. But one thing you need to know for all of them, regardless, is as you adjust one, it will make minute adjustments to the others. And what we need to do with this is, these work better with some tension on the springs. So while the springs have got some tension pressing down on them, it maintains a level better and easier. So if you wind these down almost fully, when you install the plate, incidentally, make sure that the holes are aligned properly, and it should have the white connector for the heated bed at the back. That's how you know it's the right way around. So wind these down pretty much as fully as we can without actually stressing and damaging anything, and then back them off about 5 or 6 turns, so that you've still got a bit of tension, but at the same time you have a little bit of give as well. So and speaking of a little bit of give, I actually need to adjust the eccentric up on that. So that's the build plate installed. Next thing we need to do is get the power supply wired up, at which point we need to plug this in. As regards your build plate, you have an option of stickers. I'm going to use the Build Tack type surface, and what I'm planning on doing is, because I like the removable one on the Ender 3 so much, I'm going to see if I can get one the same for the Ender 2, or failing that, get an Ender 3 one that I can cut down to size and just hold on with clips, because I really do like that. Other than that, what you can do is stick on the masking tape type surface that's supplied, or stick on the Build Tack type surface that's supplied, or even use a bit of mirror tile or a bit of glass and clip that on. It doesn't really matter, as long as you have a build surface that's suitable for your needs. So the next step is going to be connecting up the power supply, and then we'll connect, before we connect the power to the printer itself, we're going to connect all of the stepper motors and bed and everything according to the plugs, which are all labelled, so that's very straightforward. There was, in fact, one thing I completely forgot to add, which I'm just digging out of the bits box as we speak, and that is, oh, there's the bag with the bits in that I'm after. That is the spool holder, which comes with a bag with the bolts and the plastic nuts, the spool holder and the stand for the spool holder. The assembly for this bit is very, very simple indeed. It sits on the top, and I'm fitting it this way around with the insert scoop facing the front, because as I discovered with my Ender 3, one of the filaments that I use is a UK company called 3DQF, and unlike a lot of other filaments that I use, like the G-Tech, which is a very good filament that I tried, they come on plastic spools which are reasonably thin, but the 3DQF ones actually come on recyclable spools, which I kind of like. I like the idea of that. It's the metal, you've got metal sort of side bits and then cardboard tubes and cardboard outers, so once a spool's finished you can separate them and throw them into the recycle, which is a nice little touch, I think. But what I discovered is they are a bit more squat and a bit wider than your standard plastic filament holders, filament rolls. And if you fit this around the other way as per the instructions and then put your spool holder in that side, you actually lose a few millimeters and the other spools don't fit properly on them. Whereas if you fit them in this side, it gives you that extra few millimeters of room and they fit absolutely fine. So you tighten these down onto here, you fit your first plastic nut and then you just simply screw in the plastic filament holder on one side and then take your other plastic nut and screw it onto the other side, and that is your filament holder fitted. One quick tip: before you connect the electrical connectors to the stepper motors from the wires from the control board that I incorrectly called the power supply earlier in the video, I realised as I was rewatching the videos getting them ready to edit, the power supply is separate. This is the control board with the LCD screen. But before you connect those connectors to the stepper motors and the limit switches and all the bits and pieces, make sure that you've tested and adjusted all of your eccentrics and everything first, because when you move these, as you move each of these and spin the stepper motors, which are on the drive belts, especially the X and Y axis, these are more prone to the problem I'm going to mention, because the Z screw you can't move very quickly by when you're turning it by hand unless you physically sort of pull or push the axis. But as you move these, you will actually get a surge. The stepper motor turns into a generator and it will feed power back, and most people tend to notice this the first time they manually move one quickly. They go like that and the screen flashes up and they go, "Ooh, that was a bit weird." The screen flashed and lit up, and even though the power wasn't on. Now this is all well and good, but if you do that too much, you can actually get a surge of current back through the stepper motor and it can damage your board. So don't do that much at all, if at all, if you can avoid it. It might happen once, twice. Just the odd little once, twice shouldn't hurt, but be careful when you do that. If you do need to move any of these and you think you might need to move them any great amount, unplug the connector to the stepper motor before you do that, and that will avoid this happening. Now we're going to look at connecting the electrical connectors on now. These ribbon cables with the connectors on the end are already marked with these little yellow clips on the wires, and you've got a long one, a short one, one with a single large plug on a braided line. This is for the heated bed, and then the other braided line is the two spade connectors, which is for your power feed. So you've got a red positive and a black red common or earth cable or negative. So This one is obvious. It can only, all these connectors can only fit on one way, but this plugs into the heated bed. At some point I will probably print some manner of strain relief for that, because I can see that actually flexing quite a bit on the connector. So I'm not 100% happy with how that might be. But on each of the axes you will have a large connector like this, which is for your stepper motor, and a smaller connector like this, which is for the limit switch. So on this one you have a Z stepper motor and a Y stepper motor and a Y limit switch, and then on the longer one at the very end of it you have an E, which is your extruder. There's no limit switch for the extruder, it's just a stepper motor. And then you have an X stepper motor and an X limit switch. And then further down on the same ribbon cable, actually I tell a lie, it's on the smaller ribbon cable, but further down nonetheless, is the Z limit switch plug socket. And looking at this, it appears that the sensible thing to do would have been to fit this in before securing this to the rail, because the plug is now hidden behind there. So I'll have to take that off to plug this in and then refasten it. But you just fit it in and secure it so it goes to the bottom. So that's fairly straightforward. The rest of them, it's just a matter of plugging them in where they belong. So the Z1 for the stepper motor will plug into your upright. Down there. Your Z stepper motor limit switch obviously will go into the limit switch here once I've removed that. And then your Y axis, which is the bed, goes to obviously the stepper motor, the larger one just there. And then the Y axis limit switch, if I can, where's that gone? There we go. That will go underneath the stepper motor and into the limit switch over here. You might find that once you've plugged all these in, that you can actually rearrange them a little to make the routing of the wires a bit neater. So once you've plugged them in, that's not it done and dusted. You can actually unplug and jiggle them around to make the routing of the wires a bit neater for you if you wish to do so. So I'm going to go ahead and plug the rest of them in. The extruder one, it's the stepper motor is exactly the same as all of the others, but you've no limit switch on the extruder because this is just extruding plastic to the hot end. Wiring up the power supply. It's quite straightforward. So you've got your lead. You've got your little plastic base that neatens it up. You don't have to use this, but it's a good idea to do so. It's shaped so that it fits on one way specifically. So the side with the fan on, I don't know if this will be the same in all of them, but the side with the fan on in my case, the curved edge goes to, and you've got two holes in the base. One is where the power lead from the printer goes through to connect to this side of the power supply, and the other one is where your mains power lead goes through, which connects to these first three, which is your live, neutral and earth accordingly. You need to make sure that this switch is selected to the appropriate voltage for your country. 110 volts for most of the US, I believe, and 220, which is UK and I believe most of Europe as well. So you need to make sure that switch is selected properly. Feeding the cable through the plastic, you can pull that through quite a bit to begin with, and then if you arrange your wires in order, brown live, blue neutral, green yellow earth, which is a standard. Down here, I'm going to actually zoom in so you can see this bit clearer. So down here you have a cover which is numbered. Flip that up like so and it clips down into place, and what you have are screws that you can use a flat and crosshead screwdriver on, depending on what you have to hand. I'm going to use the one supplied in the kit, but I would recommend that you use a better fitting one just for nipping them up, and on it will be a flat washer. This is the bit that grips the spade type connector that you're putting onto it, or it's I suppose a fork type connector would be a more accurate description. There's probably a proper name for it for folks who deal with electrical things. So if you just happen to know what that is and you want to mention it, pop it in the comments below. Always good to learn something new. And let's try and wiggle that back in. And what you need to do is take each of your connections in turn, live, neutral and earth, and it needs to slide underneath this flat square washer, and then you tighten that down until it clamps firmly so that it's not going to get pulled and slip out or touch any of the other terminals and cause a short. So this is why I recommend you get a better fitting screwdriver. This is just for demonstration purposes so that you can see that you can do this with the supplied screwdriver, but it's not the best one in the world. So get a better fitting screwdriver. A crosshead would be my screwdriver of choice, and I will actually nip these up with a proper screwdriver afterwards. But that's essentially that. So make sure it goes underneath the flat washer, nip them up tight, and then that's your power supply connected. What you can do at this point is plug in the power supply. Obviously the earth's not on yet, so I'm not going to do this just yet, but once all three are connected and tight, you can plug the power supply in. Make sure that the power supply fan spins up, and you should see some LEDs light up inside here as well. So we'll look at that in a moment. So now that's wired up and connected and nice and tight, I'm just going to switch on the power supply and make sure that that power's up and it's okay. I would recommend that you don't fit the cover up until you've actually tested the power supply and then tested it connected to the printer, and let it run for a little while just to make sure that everything's fine with the connections and everything inside there. So just leave that loose. You can fit that at any point afterwards. So I'm just going to plug that into a spare socket, and you can see we've got a glowing LED there, and I don't know how visible that is, but we have a spinning fan. And then the usual kind of new electrical components heating up kind of smell, which is not the bad kind of puff of smoke kind of smell. So fingers crossed and what have you on that one. Fingers crossed on that one. We've got the usual, we've got this fan spinning up, we've got an LED light lit in there, and the usual kind of new electrical things warming up. First use kind of smell, which is not the bad sort of, ooh, that doesn't smell good electrical sort of smell, so fingers crossed on that one. So that one's okay. The next step is to wire in the printer onto this side, and what you have on this side is this is your voltage adjustment, a little pot down here, or potentiometer down here. It's recommended you don't mess with this unless you kind of know what you're doing, but what you can do is check the feed out on any one of these 6 connections, basically 3 pairs, and you can adjust the voltage up and down accordingly, but it should be set to about somewhere between 12 and 12.5 volts, which is all good. So don't adjust this unless you have to. If you do have to adjust this, you can actually buy a plastic screwdriver specially for this kind of job, because if you slip and touch something metal with a metal screwdriver, that's when you tend to have problems. So what you've got here are 3 common or ground terminals, negative ground terminals, and 3 positive power terminals, V+. So as long as you use them in a pair, what you can use is that one and that one, or that one and that one, or that one and that one, or that one. As long as it's a pair, it will work fine. I would recommend that you probably use the pairs furthest from each other, so you would use that as your common and that as your V positive. And then if you add a second item, do the same with that one, and a third item, do the same with that one. Because that way, if you use the ones right next to each other and one slips, and you've got, say, large connectors and they happen to touch and short out, that's where you're likely to get a problem. If you use the ones furthest away, it should be a little safer. Same thing as before, feed them through. This is the braided cable with the 2 remaining connectors on the printer. Feed them through here, and then we'll fasten them to here in the same manner as we did with these connectors. Everything's now wired together. We've got the red positive, black negative, which obviously stands to reason. They are labelled as well, but red is positive, black is negative, just in case you're not aware of that. And then obviously we've got the power from the mains over here. They're all tightened down nicely. We've tested the power supply and we know that that works. So the next thing to do is to make sure that the printer powers up and all the axes move as they should do. With the motors, the stepper motors, and all the limit switches work and stop the components where they need to. Make sure that this is switched off and plug in the power supply. So the power supply powers up, and then we'll switch on the mains, switch on the printer rather. And that is a good sign. We've got an ambient reading on the hot end and the bed, which shows that it's reading the thermistors. I am going to zoom in so that you can see the panel. So as we can see down here, we've got a basic screen, black and white screen. It says Ender. You've got the nozzle, 0 and 15 degrees. You've got the heated bed, 0 and 15 degrees. The lower one is the ambient. This is your cooling fan speed, which is currently at 1%, which basically means it's not moving. You get the exact same reading on the Ender 3, it's just that the Ender 3 is a blue screen. And then you have your current X, Y and Z axis locations, because none of these have been homed and set. Flow rate 100%, which is default. SD card icon, which there isn't one installed currently, and it says at the bottom Ender 3D ready. This would be your time elapsed just here, and then this is your progress bar down here. So the menu, by the look of it, yeah, is the same as the Ender 3. It's just a different colour screen. So if we go to prepare, you can disable the stepper motors, which will allow you to manually move everything. Auto home, bed auto leveling. Okay, I think that's different to, that one's not on. Interesting, that one's not on the Ender 3 menu, so that'll be interesting. I'm assuming what it does is it brings it down and brings the nozzle to your corner positions. Preheat PLA, which will heat your hot end. Preheat ABS, and that will heat your hot end to a hotter temperature, obviously, for ABS. And cool down and then move axis. So what I'm going to do is go into the move 1mm, and we're just going to try moving the axes. So that's the X, which the hot end, which is moving okay. The Y, which is the build plate, which is moving okay. The Z, which is the upright, which is also moving okay. Or not. It's because it's reached its 0 position, that's why. And the extruder, which is not moving, and I was wondering why. It's because the hot end is not up to temperature. I always forget that the hot end has to be hot enough to melt the PLA before the extruder will move. So what I'm going to do next is we go back up in the menu and go to control. We've got temperature, motion. That's interesting. The motion, Z offset, acceleration, jerk, etc. They're all different to what's in the Ender 3 by default as well. E-steps and everything. That's interesting. That's very good to know. Restore failsafe temperature. So, oops. If we go to temperature, we can control the nozzle, the bed, the fan speed, and we've got auto temp minimum, maximum. So we have actually got a few more options than you get with the stock Ender 3 firmware, which is interesting. I'm going to go to the nozzle and I am going to heat that up to 200 degrees. And then we'll go back to the main menu, and you should see now at the top there you've got 200 degrees and the nozzle is heating up. So I'm just going to make sure that that is actually heating by touching it. I'm not going to feed filament in at the moment because I am going to do a complete hot end strip, which I will film in a separate video, because that will be relevant to the Ender 2, the Ender 3, the Ender 5, the CR10, the CR20 and many other printers that use the same hot end. Okay, so that's heating up nicely, feeling the nozzle there, which is good. While that's heating up, I'm going to go back into, back into prepare. Let's check that. Yeah, that is heating up. Back into prepare again, and into move axis, 1mm extruder. And that should actually start moving as soon as the temperature is hot enough. Yeah, there we go. So the extruder motor is now working. That's good. We're going to go back into control, temperature, nozzle, and drop that back down to 0 and allow that to cool. As you can see, the temperature is now dropping on that. While that's cooling down, I'm going to go back into temperature and going to heat up the bed to 50 degrees. And I can feel that warming up already. So that gives you a bit of an overview of the menu. What I'm going to do is scoot back out now, and then we'll have a look at everything and we'll auto home it. So now we're all set up and leveled and what have you. The only thing left to do is load some filament. I'm going to put on some of this G-Tech yellow, which is a very nice filament. And what I'm going to do, ordinarily to load filament, you would select from the menu heat PLA or the appropriate material that you're printing, and this would heat up the nozzle, and then you could push the filament through. But because I have a file loaded ready to print, and I'm going to heat it up to temperature to print anyway, what I'm going to do is manually feed the filament in while it's switched off and cool, and push it through as far as I'm able. So cutting the end of the filament at a 45-degree angle to help it feed in. Let's just straighten the end a little bit. This can sometimes be a little fiddly, but I'm trying to do it sort of so I'm not in front of the camera additionally. So there we go. I'll push that right the way through, and that will travel all the way through until it goes down. There we go. Right down to the hot end. And then I'm going to go to print from SD, select my file, and the printer will now heat up. I'm going to keep an eye on that, and once the nozzle reaches temperature, I'm going to push the filament through to make absolutely certain that it's flowing through, so we'll be back in a moment. So that's the nozzle nearly up to temperature, so I'm just going to push some filament through quickly. Quite pleased with that. And then we're just going to allow that to start the print. And this first print I'm going to be doing is just a simple box that I designed for general storage of things, which is printed in vase mode. This is going to be something of an experiment for me, because this is the first time I've actually printed on glass. And I'm running the bed at 60 degrees because I have read from various sources that you need the bed hot to get adhesion, and then the print actually pops off when it's cold, apparently. So we will see if that's the case, we'll see if it sticks, and then we'll see if it comes off. What I'm going to do now is switch this to a time lapse, and we'll be back in a moment to look at the finished print. Okay, so here we see the print finished, and quite interestingly, as this was cooling down, you could hear the crackling, which is the plastic, obviously, as it's starting to separate. And you can see there that while it's stuck quite nicely during the print, that's just lifted away quite cleanly, and I quite like that. Look how shiny the bottom of that is. Isn't that nice? Very glass-like. Yeah, interesting. We like that. So let's peel the brim of that off, and to give you a bit of a close-up of this, this is just a sort of a wrinkly bowl, which are printed in vase mode from Thingiverse. And I've got to say, I'm really impressed with the quality of this. That is absolutely beautiful. That's at a 0.2mm layer height, and it's just incredibly nice. Look how nice and smooth that is. I mean, vase mode is always good for getting smooth results anyway, for obvious reasons, for the fact that it's just one continuous print. So you're not going to get problems like stringing and blobs and what have you, because it's not doing layer for layer for layer. It's just going continuously round and round and round. But just look at how smooth that all is. There's it's incredible. That is so nice. That's possibly even neater than the Ender 3. when I've used vase mode in that, so I think that's quite lovely. That's the Creality Ender 2. That's the build completed, and a test print, which is this nice interesting wavy vase from Thingiverse, which I think is always far more interesting than your typical sort of supplied test prints, especially due to the fact that the cat test print on the card supplied is something like a 10-hour print, which is ridiculous. So this has obviously been a very, very long video. There is a separate video which covers the disassembly and setup and modification of the hot end. I do hope that this has been useful for you if you've sat through this. It's a long video because obviously it's covered the entire process, start to finish, from unboxing to assembling and everything else. And I hope it's been useful for you. I hope you've enjoyed it. Thank you for watching, and we will see you in the next video.